Hello everyone. So in last class we studied till Coulomb's law, and what I have found that only few of you have sent any kind of notes to me or have seen the videos. I know that many of you are very good in physics, but still I am saying that class 12th physics is quite difficult. So please pay attention and watch the whole videos. I know there are very good resources available on the internet and you can study there. But let me tell you why I am doing this rather than sending video from other sources. First of all, the videos from other sources are not personalized for you. They don't know your need. Second thing is that they are teaching only the few important concepts, not the from the book, while I am teaching from the book, chapter by chapter and topic by topic. So your fundamental understanding also develop with this. So that's why I am doing this. So we are just going through the book. I know that I am not very good as some other resources out there because they have availability of animators, good animators. I don't have animation because I am alone. I don't have any board at my house, and if I start preparing PowerPoint presentation, I don't have a whole team, but these agencies, very big agencies, have people who create PowerPoint animation and then narration, but I don't have. And even I don't have a board right now. What I have is my computer screen, a PDF which I have already sent to you, and I am recording this voice from my headphone. So please pay attention. I am doing my best. I am also investing many hours per week just to prepare these videos, uploading these videos, and then answering your queries. So please I request you once again to pay close attention to these videos and understand the concepts, because I know you and these videos are personalized for you. So let us start today's topic. Even on that day we started with Coulomb's law. So our topic is Coulomb's law. So on that day we saw that Coulomb's law is very similar law for electrostatics, and on that day we also discussed that charge can be in two types, in electrostatics and electrodynamics. While in our wires charge is moving, that is electrodynamics, a high amount of charge, that is many coulombs, because 15 ampere plug is common plug, so that can handle 15 coulomb charge per second, so that can handle a high amount of charge. But in an electrostatic, the charge of 15 coulomb is quite high. The reason is that flowing charge takes some time, though 1 second is very small time for us, but for charge it is very big time. So charge can migrate in that time, but 1 coulomb of charge is staying at a single place is a very big unit, and we saw that there is a high amount of force, or 9 into 10 to the power 9 Newton between two spheres having 1 coulomb of charge, either repulsion or attraction. That is a separate issue, depends on charges. One is positive, another one is positive or negative, that depends on that. So but the amount of force is quite high. So let us see what is Coulomb's law. So Coulomb's law is very similar to gravitational law. Here we calculate the force, there is a constant and two charges, charge is q1, charge q2, and the distance between them is r, okay, and square of that. So how we prepare this law, how Coulomb has derived this law, is that take one charge q1, another charge q2, and the distance between them is r. So the force between them is proportional to first charge, magnitude of first charge, magnitude of second charge, and inversely proportional to square of the distance between them. And definitely there must be a constant of proportionality that we will calculate later. So this is Coulomb's law. Remember one thing, here it is in mod. The mod means that whether this quantity is positive or it is negative, it always comes out as positive, because here we are seeing the magnitude of force. Here it is clearly mentioned, magnitude of the force, not the direction of the force. Now what about the direction of the force? Let us understand this. Suppose if apart from direction, apart from magnitude, if we want to see the direction, if one charge is positive, another charge is negative, then there will come a minus sign. There will come a minus sign, as you know that positive and negative attracts each other. So when force is negative, then it is an attractive force, and there must be a unit vector r associated with this, which points out in which direction force is there. Okay, a unit vector r. So this is whole formula, but for the timing we are moving this and we are considering only for the magnitude of this force. So let us go further. So I hope till now you have understood this story, that how did Coulomb arrive on this equation, and you must read this story. So now let us understand this. So even on that day we discussed that if we put charge q1 and q2 is equal to 1, that is both the charges are 1 coulomb, and the distance between them is 1 meter. 1 meter is quite high distance. The force is, as I had already said, is quite high, 9 into 10 to the power 9 Newton. This is a huge amount of force. You can move many big things with this amount of force. Okay, so that's why smaller units of charge like millicoulomb and microcoulombs are used. Millicoulomb, please remember that you have to do these exercises. Millicoulomb is 10 to the power minus 3 coulomb. Milli means 10 to the power minus 3, and microcoulomb means 10 to the power minus 6 coulomb. Okay, so you have to understand this, and then using this they have evaluated this constant k. So what is k comes out to be? K comes out to be 1 upon 4 pi epsilon naught. 1 upon 4 pi epsilon naught. This is the value of k, 1 upon 4 pi epsilon naught. So q1 q2 upon r square remains the same. So when we do the maths, we get a value of 8.85 into 10 to power minus 12. Please remember the unit coulomb square per Newton meter square. You can again calculate the unit using this as well. Force is in Newton, so take this epsilon on this side, F down here. So Q1 Q2 coulomb square R square per meter square per Newton. This is the unit of this epsilon naught, permittivity of free space. So why it is free space? So here we are assuming that the charges are separated by vacuum or at most air. The permittivity of air and vacuum is almost the same. If we take permittivity of air and permittivity of vacuum, so we can take that permittivity of vacuum and permittivity of air is almost the same. So this is till now, and you have to remember this unit. This will come in many other examples, so please remember this. So after this we are going to see this Coulomb's law in different conditions.